Picture standing at the edge of a canal. A cargo ship, the size of a city block, noses into a concrete box barely bigger than itself. Two gates swing shut behind it. And then, with no crane and no engine straining, the whole ship starts to rise, climbing a hill full of water. I am Alex, and this is Unseen Systems. So how does a canal lock lift a 3,000-ton ship uphill without ever picking it up? The answer is almost suspiciously simple, and it has not really changed since the 1400s. Let's trace one trip through the lock. Begin with the weight. A ship like this can run 3,000 tons fully loaded, and the machine that raises it uses exactly 0 pumps. One thing to fix up front, my numbers here come from real locks, mostly the Panama Canal, and the exact figures shift from one canal to the next. The rule underneath never does, and in normal operation, no pump ever lifts the ship. Here is the setup in cross-section. Our ship waits in the lower pool, the downstream side sitting low. Ahead of it is the lock chamber, and beyond that the water is much higher. The job is to get from the low water up to the high water. The ship moves into the chamber, and the gate behind it closes. Now both gates are shut, and the ship is sealed inside a watertight concrete box, cut off from the low pool it came from and the high pool it wants to reach. Above, held back by the upper gate, sits the upper pool, the high water, meters higher than the ship. Every canal does this in steps. On the Panama Canal, one step lifts a ship about 9 meters, roughly the height of a 3-story building. Now the trick. An operator cracks a valve near the floor of the chamber, opening a culvert, a big pipe built into the lock wall that connects to the upper pool. Because that pool is higher, gravity simply pushes water through and the chamber begins to flood. A big chamber can fill in about 10 minutes. And as the water rises, the ship rises with it, floating the entire time. This is the part worth holding onto. The lock never lifts the ship. It lifts the water, and the ship just floats on top, which means a fully loaded 3,000-ton ship costs no more to raise than an empty chamber, because all you were ever moving was water. But that raises a harder question. If the chamber is holding back a wall of water meters higher on one side, what keeps the gates from simply bursting open? Look at one gate from above. It is not one slab, it is 2 leaves that swing shut and meet in the middle. And they do not meet in a straight line. They meet at an angle, forming a shallow V, and that V points upstream, straight into the high water. That one detail is the whole secret. Because downstream, on the far side, the water is lower. So this pair of gates is the only thing standing between the high pool and the low one, taking the full push of all that water. Here is what the V does. The high water shoves on the gates, and because they angle into it, that push wedges the 2 leaves together at the point and jams each leaf back into its socket in the wall, the coin. No latch, no lock holds it. The harder the water pushes, the tighter the gate seals itself shut. Leonardo da Vinci sketched this design in the 1400s, and we still use it. So the gate is not fighting the water, it is using it. On the biggest locks, a single gate leaf weighs over 600 tons, and the only thing keeping that 600-ton door closed is the weight of the water leaning against it. So the lift is free, and the gate holds itself shut, which makes you wonder where the hard engineering actually is. Follow the water. Every time our ship locks through, it fills a chamber, and when the next ship comes down, all that water drains out into the lower pool and just keeps going downhill. And that is a lot of water. One lockage on the original Panama locks spends about 101,000 cubic meters of fresh water, roughly 40 Olympic swimming pools, drained toward the sea. In the drought of 2023 and 2024, the lake feeding the canal dropped so low that Panama had to cut how many ships crossed each day and how deep they could sit. The lift was never the problem. The water bill was. So modern locks fight that bill with a clever add-on, water-saving basins. They are shallow ponds sitting beside the chamber, at stepped heights, one high, one in the middle, one low. Watch what they do on the way down. Instead of dumping the whole chamber downstream, the lock drains it into those basins one at a time. The high basin catches the first slice, then the middle one, then the low, and only the last bit is actually lost. Then on the next lift, those basins pour their water back into the chamber first, through the very same culverts, so the lock only tops up the rest from the pool. Panama's newest locks recover about 60% this way, drawing only 40% fresh. The idea came from canals in Germany and a giant lock in Antwerp. The real engineering was never lifting the ship, it was learning not to waste the water doing it. There is one catch in all of this elegance. The gate that seals itself with water pressure is still, in the end, just a gate, and a lock usually has no way around it. If it breaks, the whole waterway stops, and a gate is exactly the kind of thing a ship can hit. On the 8th of December, 2024, on the Moselle River in Germany, an inland cargo ship carrying 1,500 tons of scrap metal came into the Müden lock and failed to stop. It struck the closed gates head-on.
Both lock gates were torn loose.
Both gates were ripped from their mountings. Around 70 vessels were trapped. The Moselle, a river that had moved over 8 million tons of cargo that year, was closed to through traffic, and the repairs stretched into the following March. One misjudged approach, and a self-sealing gate that had held the water back perfectly was simply gone. So hold the whole machine in your head at once. The ship floats, so its weight never matters. Gravity moves the water, so no pump does the lifting, and the gates are shaped so the water locks them shut for free. 3 simple ideas stacked, and a 3,000-ton ship walks up a hill. But what matters most here rarely gets said out loud. The interesting thing about a lock is not that it can lift a loaded ship for free. Gravity has done that since the Renaissance. It is that all the modern cleverness goes into the opposite problem, not spending the water to do it. Because the water, not the lift, is the thing that runs out. So a lock isn't really a lifting machine at all. It borrows the weight of the water to carry a ship uphill for free, and then spends its cleverness trying not to waste that water. Stand beside a working lock sometime, and don't just follow the gates as they swing. Watch for the shallow ponds off to the side, quietly saving it. Keep watching the water do the clever work, engineering fans, until the next system.